great prestigious posts around the U.S. He's ended up again at University of Michigan as both the Dean of the School of Natural Resources and Environment and also a professor there. Most of his work, as you know, centers around stream ecology, all things river really, with great emphasis on changing land use patterns and its effects on stream ecosystems, and lately more into biogeochemistry, which he finds himself surprised at. He's done sabbaticals all around the world, including Sweden, England, Israel, Venezuela. He has quite a breadth of international experience. And when I asked him a few personal questions, he said his favorite field work was in Alaska, in the Tongass, or Venezuela. He's not quite sure which. And his favorite travel is yet to be taken. In a couple weeks he's going to Antarctica, and he anticipates that'll be his absolute favorite. And in his free time, he's like many of you, I would say the vast majority of you, he prefers to be on the water, paddling or fishing. So without further ado, I introduce to you Dave Allan, and I hope you enjoy the talk.
Well, thanks very much, Kathy, for that introduction. Thank you for the opportunity to be here. I'm really honored to be part of the Devon Lecture Series. I know this is a wonderful lecture series. Is the microphone working in the back of the room? Can you hear me okay? Perfect. So I know this is a wonderful lecture series you have, and I'm just really pleased to be here as part of it. So let me find my slides and launch in. Thank you. So what I want to talk about is sort of several stories that have to do with the protection of freshwater resources. And this will include a number of fisheries-related issues as well as other issues that have to do with the threats that freshwater ecosystems face, which are very diverse. So this is basically an outline of my talk. I want to briefly introduce that threat medley. I think it'll be familiar to you. I won't spend a lot of time on it. Then I want to talk about overfishing as a underappreciated and under-researched threat in freshwater systems, and talk beyond that into the topic of how we might think about protected areas for freshwater, and finish with a particular case study that's actually a recent PhD thesis of one of my students focused on the freshwater fishes of Belize. And throughout this, you'll see a certain amount of marine envy. A lot of the motivation of these particular projects has been to say, well, you know, the marine fisheries guys have spent a great deal of time, there's lots of issues still to be resolved, but a great deal of time thinking about and trying to evaluate the impact of overfishing in marine systems. What do we know about this in freshwater? When it comes to protected area planning, there's really a long history of well-developed algorithms and methods for designing protected areas. All the conservation biology literature that's focused on the ways in which protected area planning should take place. Marine protected areas, not so new anymore, but still relatively recent, and been a great deal of literature on that. And actually, this topic came from one of my former students, who's a freshwater conservation biologist with the World Wildlife Foundation, Robin Bell. I'll mention her again. And she was saying, you know, we know that there's really important needs for freshwater protection, but we don't have a body of literature that we can point to as the rationale, the justification, and the fleshed out thinking about this. And so a fair amount of what I'm talking about today has been in partnership with Robin and others, attempting to look to terrestrial research, look to marine research, and see if we could develop some ideas that would move freshwater along a parallel track, maybe not the same track, but a parallel track. So this graph for me is a big part of the motivation. As a freshwater biologist, I'm struck by the fact that when you look at a list of the imperiled species in the U.S., at the top of the list you see 1, 2, 3, 4, 5 species of 5 major taxonomic groups associated with freshwater ecosystems. The most imperiled species, according to NatureServe, have some association with fresh water. I don't want to get in a competition about whose system is most threatened, but it certainly is a suggestion that we should be paying more attention to the challenges that face freshwater systems. We know there's high rates of extinction for freshwater taxa. Over half of recent birdwood extinctions have been of freshwater-dependent species. And we know there's lots of threats. It's really a medley of threats that involves habitat degradation and loss from a variety of sources, both in-channel things like dams, and off-channel like land use. We have severe pollution, invasive species, climate change, and then overfishing, which doesn't get talked about as much, in my experience, in the freshwater setting. And so the first part of the story I want to present to you is an effort that a group of us did to just see if we could pull together what we knew, what was known, to start to ask some of the pretty obvious questions that you would, any marine sciences course on overfishing you talk about. Well, what can we say for freshwater systems? And again, I think this is a popular graph here. You all know this particular chart. I'm not suggesting that it's the true representation of marine overfishing, but it's sort of dramatized. It's, for me, the way in which people have really attempted to think about overfishing in marine environments. Another graph that might be familiar to you shows the global fish harvest. Marine and freshwater total. This is Millennium Ecosystems version of the graph, which is corrected. I never quite figured out how they corrected it, but this is the correction that is intended to compensate for presumed over-reporting, because the numbers are up here somewhere. And it gives a different sense, though the line is going straight up. It says, well, we've plateaued or declined slightly. Here's another graph that shows the world catch of both wild and farmed fish. And if you look at a graph like that, you have to ask yourself, does that graph actually tell you that you're in trouble or not? And people in this college have done a lot of writing on the state of marine fishes. So we just wanted to, again, think about freshwater, went to the FAO data. And so this is a compilation from the FAO database for freshwater or inland water fisheries. And it shows, these records start about 1950. And it gives you that same sense of just a continual rising harvest, maybe showing some little sense of leveling off, but it's certainly not a rise and a crash. So that's one thing to note about this. The total is about 9 million metric tons, so roughly 10% of the marine harvest. Not nearly as big, but very important for some people. A couple other points these graphs make. If you look at the graph for Asia, and just look at the scale, it goes to 6. Look at the graph for Africa, and look at the scale, it goes a little over 2. It's pretty clear that Asia and Africa are pretty much all of the world freshwater fishery catch. The South American component in other parts of the world is essentially trivial. So these are the two places where it's all happening. And the Asia graph is interesting to look at because it shows this particularly rapid acceleration in the last decade and a half. And what again, the marine literature tells us is to be wary of the reporting from China. Polly argued in a paper some years ago that the reporting for marine catches from China were out of line with expectations of productivity of those systems. When that report came out a few years later, China froze their reporting at the level they were reporting up until then and haven't changed it. And so you see this kind of funny graph over here. Ignore the lower part, which is probably any number of explanations for why things bounced around in the 50s and 60s, but you can see how China's share really has risen dramatically, and then as a percentage it's dropped off because China's frozen its reporting. So this is all a reminder that these data are only so good because they're countries' self-reported data. And the data for freshwater fisheries actually have a number of challenges in addition to that, which is that for the most part, these are not the large industrial, well-regulated fisheries from which there's good landing data. For the most part, these are dispersed fisheries that are often relatively small scale. Many are in developing countries, many are subsistence or artisanal fisheries, and so the general consensus among the people who study these data is that underreporting is probably rampant. And so there's a mix of underreporting and overreporting in here. You simply have to take the information with a grain of salt. I'll come back at the end to make the very obvious point that we simply need better reporting to be able to understand better how these fisheries are progressing. So a few summary comments. It's around 8 or 9 million metric tons. Aquaculture is bigger than the wild catch for freshwater, the reversive marine systems. So about 2-3 times, well, at least 2 times as much freshwater aquaculture as wild caught fisheries. And for all fisheries combined, they are important to people. 15% of the world's protein, primary protein source for at least 1 billion people. But again, when you dig into the inland fisheries, the freshwater fisheries story, it's really hard to come up with good numbers. There's no global estimate of numbers involved. Carmen Revenga in our team was one of the people who helped with what information there was available. And these are just very approximate numbers that suggest that there's tens of millions of people involved in freshwater fisheries. But they're often involved incidentally, episodically, often as employment of last resort. People will farm for part of the year, or they'll be farmers until their crops are not doing well, and then, but if there's abundant opportunities to fish, then they'll switch to fishing. So there's this kind of shift among sectors with people farming part of the time, fishing part of the time. There's a story you may have seen, this came from the marine literature off Africa, where when certain artisanal fisheries failed, people who were living at a fairly subsistence level switched to the other available wild meat, which was bushmeat. And so poaching in game parks became the substitute for a collapsed fishery. So there's this notion of employment of last resort, of people moving in and out of the fishing sector. And then something I found very interesting that is, I think, perhaps also maybe a little bit different. You can tell me if I'm wrong on this. That perhaps in contrast to a marine system, in many parts of Asia and Africa, which remember is where most of that freshwater fishery occurs, people aren't fishing for fillets, they're fishing for sauces. They're using every size of fish. They're making sauces, they're making paste, they're making flavorings. No fish is perhaps too small for that purpose. And so you'll see sort of a mixed story here. That's actually a takeaway message, a sort of mixed story about the freshwater fisheries that we've been able to put together. You know, on the one hand, you have fisheries that are focused on really large fish. That some of the great freshwater fish of the world that are shown in this diagram. And those fisheries, perhaps focused on individual species, look more like a conventional single focused fishery, showing some sort of a yield curve that would be illustrative of overfishing with a maximum yield and a collapse at higher effort. This is the fish being illustrated. That's probably the largest freshwater fish in the world, if you exclude the sturgeons, anadromous sturgeons and sturgeons of the Caspian Sea. It's probably the largest individual freshwater fish in the world. That was a photo in the New York Times. It's a 610-pound, I think, giant Mekong catfish, which are very, very imperiled species. It's unlikely there's another individual as big that still exists. So that probably is the biggest freshwater fish ever on record. And at the other extreme, there's these kinds of fisheries, again from the Mekong. And it's just Zeb Hogan took always wonderful photos who works in this area. And it's just stunning to me to see the density of fishing boats, all the little dip nets on the front, floating villages of people living on the Mekong River, these bag nets that bring in really large numbers of small fish, and these other fence-like systems for fishing. And this probably illustrates, I have a graph coming up that relates to this, probably illustrates something that might be somewhat common in freshwater fisheries, which we describe, actually colleague Robin Welcome described, as assemblage fishing, where the target is not individual species, but an assemblage of fishes. And I don't know if the fishermen know the names of the individual fishes they're catching, but for all practical purposes, it's just a whole bunch of cyprinids that are coming in. And there's no reporting by species, there's no individual species data, and they're fishing an assemblage of small species that are used in, as food for pastes and soups and so on. And it's a few sort of words to walk through this diagram. This is a conceptualization of what a yield curve might look like in this, particularly for this assemblage fishing pattern, where as the effort increases, the yield increases, and imagine, if you will, that there's actually a series of species. This is hypothetical, but imagine that there's a series of species that might themselves be being overfished, but since you're not reporting out species by species, you simply continue, even though you're fishing hard on that assemblage, you continue to have sort of a plateau, long plateau of fishery yield until there are more species to go to. So this is an assemblage that's being overfished, not a single species. You would expect, the classic fishing down sort of picture, that often large species will be removed in large individuals, and then smaller ones as the exploitation timeline progresses. And so you would see that whether you measure fish size or whether you measure some gear, like net mesh, a mesh of net. But another complication that we think is worth keeping in mind is the way in which the sort of the technology of the fishery, if you will. And so what this is contrasting is a fishery, a multi-gear fishery, in which, because there's a wide range of targets, there's a wide range of gears being used, and sophisticated artisanal fishermen, local fishermen, with a whole variety of weaponry of nets and traps of different sizes, all of which are deployed, can, from the very beginning, catch a wide variety of species. This is the number of species harvested. And over time, they would be expected to deplete those. That's in contrast to what you might expect with a more sophisticated gear like gill nets, where initially those gill nets are often targeted at certain species, usually the largest individuals, so they're larger nets, larger mesh size, and they're going to catch relatively few species because they're targeting the larger individuals and species in the system, which are generally less common than small species. But as they work their way through the assemblage, the only way they can maintain this plateau is to continue to sort of move through the species assemblage, and moving through the species assemblage often means moving down to smaller species and finer net sizes. And so as you move down to smaller species with smaller net sizes, you actually move to the more diverse part of the assemblage. There's more species of small fish than there are large fish. And so these are some contrasts that we think are potentially happening in these fisheries. But these are just hypotheses. Without good catch data, it's really not possible to say whether that's what's truly happening or not. But it's a way of thinking about assemblage overfishing that's different from species-targeted fishing. It's certainly true that most fish species are small in freshwater. So this includes species not just from North America, but from South America and Africa as well. And what it is just a ranking of little fish to big fish. So the horizontal axis is the maximum length to which a species would grow. And the vertical axis is the number of species in that size range. And I think this is kind of remarkable. Half of the species pool, this is a very large collection of data, half of the species pool is less than 15 centimeters long. 90% of the species pool is less than a half a meter long. So this is perhaps different. Looking at the fish on the walls in this building, and you've got a very unrepresentative group of fish mounted on your walls. All these fish that are out here are unrepresentative of the species pool that actually exists. But Pacific Northwest is different. It's certainly true that bigger species are more likely to be piscivores, so when you take out the bigger species, you're likely to take out the apex predators. This is a data set from West Africa, and it simply shows the fraction of species that are piscivorous against their size. We're up here at a 1/2 meter long again. And it's certainly true that as you get to larger sizes, they're more likely to be piscivorous. But there's certainly lots of exceptions. There's large detritivores out there. There's large herbivores out there. So if the large fish are eliminated, then the potential exists to alter food web dynamics by removing apex predators, which is, of course, a story that we've all heard. And I put in this one example from some colleagues in Venezuela, Brad Taylor's work with Alex Flecker and Bob Hall. Quite a nice story, just to illustrate that we do see fishing down occur in freshwater fisheries. This is Procholotus. It's a characin. It's actually a detritivore, and it's a migratory fish, which spends its part of its time in the floodplain rivers, and then during the low water season, actually it migrates up into the headwaters where it feeds its sediments on surfaces. If you've seen any of Alex Flecker's excellent work on ecosystem engineering by a detritivorous fish, it's this guy. And this is the most common food fish in South America. It is, to my knowledge, the only species of fish for which catch is recorded by species in the FAO database. Otherwise, it's just total catch. So we know a bit about it. And I've worked in these same areas with these guys. And the local fishers generally use these wonderful circular cast nets. And they're just so proficient at throwing those cast nets out in a medium-sized river and scooping up Procholotus, which are often sold on the side of the road or in the market. So it's one of those sort of artisanal subsistence-like fisheries. And one of the guys that we work with there, a local guy, makes nets for the fishermen. And the way they measure nets in that part of the world, at least, is by the number of fingers that the mesh size is. So Junior, the guy who's helped Brad with this information, was saying that he used to make 4-finger nets, meaning that the mesh size was fairly large because that circular catch net, the fish were large enough they couldn't get through. Then they started making 3-finger nets, then they started making 2-finger nets. And so it's the classic story of the decrease in size of the gear reflecting the adaptive response of the fishers to the decrease in the size of the fish available. And this is a corroborating data set. This is the body mass of Procholotus in museum collections in South America. And probably not the most perfect database. You take what you can get. And it shows that when people were tossing fish into jars in museums in the 1980s, they were a lot bigger than the ones who are tossing in jars in the year 2000. So we do have fishing down. We do have impacts on apex predators. But story I want to tell that really credit Stuart Rowland of Australia for help with putting this story together, of the sort of contextual framework of overfishing in freshwater. And perhaps it's equally complicated in submarine systems. But I just thought this made a nice illustration of how you couldn't separate overfishing from everything else that was going on when you looked at the collapse of the fishery. So the Murray cod, freshwater fish of Australia, largest freshwater fish. The indigenous people legend has it that this fish dug the rivers of Australia. This fish would make the rivers by burrowing through them with its snout. And it was an important fishery at the beginning of the last century. So these data, this is not a great looking graph, it's a photocopy of an old report, show the railroad consignments for Murray cod going from the countryside to the cities, to Melbourne and Sydney, to the market. And this fishery took off around 1900, and the historical accounts and the people who've researched it believe that the fishery was simply overfished by about 1920, collapsed, and then there was a period of time where there wasn't a lot of fishing activity. The fishery had evidently collapsed. The Great Depression comes in here, and people simply, there was less commercial fishing for Murray cod. And then at sometime in the 1940s, commercial fishing for the Murray cod took off again, showed another peak, and then sometime about 1960 went through a real downturn, and except for that one little, perhaps aberrant bump there, just stayed low in the 1980s. But in this case, this looks like a recovery from overfishing. That's how it's interpreted. The collapse is probably not specifically overfishing, because this is about the time period when dams and weirs became widespread in Australia. And so river regulation and the separation of lower rivers from upper rivers became more of an issue. And then somewhere in here, yellow perch were introduced, and yellow perch were an effective competitor with the young cod, as well as egg predators. And so the decline of the Murray cod here seems to be one of these lots of reasons: overfishing, habitat damage from dams, invasive species. And the last part of the story, of course, is the recovery story. And so now they've developed effective hatchery techniques. And so these are stockings. These are fingerling stockings in parts of the Murray system, which have increased quite dramatically as they've gotten better and better at their hatchery methodology. And so now the Murray cod is making a comeback. It's turning into a recreational rather than commercial fishery. And I think it's just an interesting story because it says that you can't explain it with any one part of the story. And that explanation I gave you may not be all of the story. It's all we can put together at the present time. There are two papers. I was looking at some of the studies that people have written since we published this paper to see what I might tell you that was new. And there's two papers I want to mention. I quite like this paper. When we were writing our overfishing paper, and Kirk Weinmiller was a co-author, he was pushing really hard to put in more history of overfishing. We were up against page limits and trying to do a balanced story. We really couldn't do it. So just recently, Kirk and a co-author put out a paper in Bioscience on historical impacts and shifting baselines of freshwater fisheries. It's a really nice paper. And so he basically runs through a whole series of case studies of the history of overfishing. All big fish, well, pretty big fish, most of all bigger than half a meter, maybe wise, and points out that overexploitation has been a major factor for at least 100 of the several hundred threatened freshwater species in North America. And I haven't had a chance to talk to Kirk since this paper came out. I think it's a good paper. I think it's part of the story. I really, really like this paper. I'm not persuaded that it's the whole story. That the historical focus on overfishing takes you to a certain number of species, the large fishes, the ones that have the most commercial value, and so it's a piece of the freshwater story. But I don't know if it's the whole story. And I like this paper of Julian's on extinction risk and body size, and I presume everybody here has read this paper and tested on it. So I'll just remind you of a couple of the highlights of this very nice paper that Julian and others wrote, where they looked at the threatened species from the red list, and they compared the threatened species, basically looked at the body size, where threatened species, from the larger spectrum of the body size, the smaller spectrum, all over the range, separately for marine fishes and for freshwater fishes. And what they reported was that for marine fishes, the threatened species were the large species. And it really, I think, and again, many people here are expert on this, ties in with the sense that marine fisheries, marine fish are threatened more than anything else by overfishing. That overfishing targets large species. It all seems to be part of the same story. What Julian's team found was that for freshwater species, you couldn't make the same claim. They actually found a tendency for smaller body species to exhibit greater risk, with one exception, and that was for certain freshwater species that had been the ones that had the greatest commercial value, then it was the larger species that were threatened. So to me, it ties in with this notion that freshwater fisheries are different in lots of ways. One of the ways in which they're different is the size categories that are targeted aren't. It's not this start with the largest and work all your way down. Most of the fishing is taking place in Asia and Africa. Cultures that use fish for paste, for soups, for flavorings. They take place in the tropics. The greatest number of species are small individuals. And so there's a mix of pressures across the size range. And you can go to the freshwater literature and select out very good case studies of large-bodied species that have been commercially fished, that have been fished down as individual species, very much in the way we see in the marine system. But I think if you look across all of the spectrum of what threatens freshwater fishes and the role overfishing plays in it, you have to look at a much more complicated story. So some obvious things we need. I'll just focus on the top one. If you don't have landings by species and location, you're really challenged in the amount you can infer about the health of those fisheries. So we're just way behind. And I understand that some people in this room are working on rectifying that, and that would be really good. So we really wanted to bring up some of these issues that we knew needed more attention. And that paper was really a prelude, as this part of the talk is a prelude to where several of us, Bob and Allan and myself in particular, wanted to go, which was to think about freshwater protected areas. And again, we see all this interest in marine protected areas. We know there's a well-developed literature on terrestrial protected areas. We're feeling left out. We want to see something more about freshwater. We wanted to again see if we could help start that conversation. And there's lots of reasons, perhaps, why the freshwater protected area topic has been less attended to. The whole notion of setting aside an area really raises issues. I have to tell an anecdote. I was one of a group of people that early on became a science advisory group to a very good organization called American Rivers, which focuses on freshwater conservation. And they were really trying to develop their sort of theme and their message with a science base to it. And they started talking to us about, a group of us, about freshwater protection and watersheds and riparian buffer strips and so on. And the president of the organization, a very savvy guy, but not really familiar with the sort of science side of freshwaters and the policy part very well, said, well, it sounds like watersheds are what we want to focus on. Let's focus on watersheds. And I said, yeah, it could be a good focus. And then I think it was either later that day or the next day, he said, wait a minute, watersheds are everything. We can't do that. That's not the least bit practical. We can't protect all watersheds. That's like the whole landscape. We said, well, yeah, that's part of the problem. You're right. And they eventually settled on what I thought was a very smart outcome, which was that the American Rivers today, you go to their website, their mantra is protect the headwaters, protect the corridors, protect the floodplains. So it was sort of a spatially distributed thinking about what protection should be. That's what I'm going to get to as well. But there is this notion of people are everywhere in watersheds. There's so many conflicting purposes. The whole idea of setting aside anything big enough to matter seemed like a real challenge. And then there's all these longitudinal connectivity issues. Maybe that was holding things up. If you look at something like the World Database on Protected Areas, you don't find anything on rivers. One reason is they record their units to the power of 2. They record area. They don't record length. So there wasn't really a good way in their accounting system to even think about rivers. Ramsar sites are probably the one place where there's existing freshwater protected area framework, and that's good. Focused mainly on wetlands, targeted mainly at birds, so not really as much as we wanted, and as we think was necessary. And then if you ask the question, how much area is protected in freshwater today, rivers today, there's no number in the World Database of Protected Area. You can't really answer that question. So then we were intrigued when the Millennium Ecosystem Assessment reported that 12% of the world's fresh water was protected. How'd they get that number? Well, it turns out that they started with the number that 12% of the land area was protected. They overlaid the hydrography, and bingo, 12% of the water was protected as well. If you believe that terrestrial protection equates into a freshwater protection, then maybe that's a good answer. We've actually got a paper in press right now that for Michigan that shows it doesn't do that good a job. But clearly that's not satisfying to say, well, 12% of the land's protected. Overlay the rivers, you got 12% of the rivers. That's not very satisfying. So, got us into a whole discussion. What's different about freshwater? How does place-based solution translate there? What's that interaction? So one of the things we published in our a paper on this was a table that, if nothing else, is good for graduate student seminars to have these kinds of discussions. I think everybody has an intuitive sense that there's a difference between terrestrial landscapes, marine systems, and freshwater. When you try to actually get specific about it, it's a challenge. I feel pretty okay with this. 11.5% of terrestrials protected, less than 1 of marine. Don't know. Focal features, often biodiversity targets over harvest protection. In freshwater, we often characterize system sites and try to get representation of system sites. That's where a lot of the freshwater planning is right now. I don't know if I want to walk through all of this. Connectedness, terrestrial systems, of course we're familiar with the importance of resolving isolation of corridors, but to a large degree, those individual units are thought to be self-sustaining and have appropriate connectedness for rescue effects and so on. Marine systems, I think of as being highly open. Freshwater systems may be somewhere in between, but connectivity, again, very important. Upstream, downstream, land to water, surface, subsurface. Scale of protection, emphasis on boundaries. I think more of an emphasis on population responses. Probably more similar to thinking about boundaries for freshwater. And then ownership, another set of major differences. So I don't claim that's a perfect characterization. I'm sure you could find an exception to one of those. But it's just an effort to say, well, maybe there's something about freshwater that's a little bit different. We should at least keep that in mind as we try to do our planning. And the other thing that sort of goes along with this, and it's really hammering at the connectivity issue, is we sat down with a series of what we thought were major threats to a freshwater ecosystem, and described here, and tried to think through, did they tend to originate at a local scale, right at the spot you were concerned about? Did they tend to originate somewhere else in the catchment, but still in the same catchment? Or might they be extra catchment in origin? And this side of the graph, I would argue, says that often the threats that you're dealing with with a freshwater system are not of local origin. So again, spatially distanced threats are issues that have to be taken into account. So the spatial distribution keeps coming back at us. I'm just going to go right to here. This is a bit of an aside, but I think it's an interesting one. It's sort of a counter to something I said earlier, which is that we can't protect a big enough area in freshwater to matter. Not sure for some criteria that that's true. This is a classification of stream size. First order is small, third order, sixth order is fairly large, ninth order is like the Ohio or the Columbia. So there's lots and lots of little streams and a few big rivers. This is their average length. We know these because there's various geometric relationships between river size and drainage area and floodplain width. And actually, not out of the realm of possibility to protect the entire drainage area of the third order river. 50 to 100 square kilometers. Not, so that's what, 5,000 to 10,000 hectares. Not out of the realm of possibility for a small system. In fact, if you just want to protect the floodplain, you can do that for even a fairly large system. So there may be places where we can actually protect everything. But there's probably lots of situations where we can't. And so what this part of the talk is about, and the paper with Robin and Bernard is about, is the notion that maybe we needed to get away from thinking about contained areas as being a single area that contains everything that matters to that set of targets we're concerned about, and think about something that was much more spatially distributed, that was much more accommodating of human presence, that had more process focus, with connectivity being really a major part of it, and it would address the special attributes of freshwater system, including remote threats, lack of data, and ultimately tie in with, and this I think is where we want to head in the long run, is that freshwater protected areas, terrestrial protected areas, marine protected areas need to be thought of in many cases in an integrated fashion. So this diagram kind of sums up the one picture, the framework that we felt we wanted to advocate for. And so the starting point is focal areas, and focal areas are associated with something you care about. It's a species, an ecosystem type. So it might be a particular wetland, it might be a particular lake, it might be these headwater streams that contain some threatened species. So if you could work with just a small little park, those would be it, you'd be done. But we argue that you can't, in freshwater systems, get away with that. That you have to manage what we call a critical management zone that may be upstream or may be downstream. It may be downstream because of fish migration. It may be upstream because of land use factors. It may require the entire catchment to be protected. It may be sufficient to use a buffer strip framework. But really, the focal areas have to be connected to management zones. And those management zones may be spatially distant. And then the third part of the framework is to embed it in a catchment itself. So this would be your integrated river basin management or your whole catchment management. And it seems like a small thing, but it's really one word that changes. The of becomes for. Instead of protection of freshwater, it's offering protection for freshwater using a spatially distributed framework. So the last part of the talk I want to present is an attempt to test that idea that worked with one of my recent PhD students, Pete Esselman, and the focus was the freshwater fishes of Belize. And I wanted to remember to mention that when Robin and the rest of us published our paper in 2007, she did a Web of Science search on the phrases of freshwater protected areas. She had 14 hits. There were 14 papers we could find that had something to do with freshwater protected areas, so small literature. I did another review before coming for this talk, and it's about double. And our paper's in a special issue of Freshwater Biology, which is going to triple. So this is starting to see a real growth, which I think is wonderful, diversity of approaches. So what Pete felt he would do is apply this idea of having focal areas, critical management zones, might be upstream to protect from land use, might be downstream to provide a migration corridor, and embed it in a catchment management zone. And the work takes place in Mesoamerica. The study area actually includes parts of Mexico and parts of Guatemala, and these are streams, river systems that drain to the coastal waters of Belize. So looking at these river systems that drain to the coastal waters of Belize, a little bit about the setting. Elevation differs. Northern Belize is relatively flat, limestone. Southern Belize has the Mayan Mountains, more elevation topography, more granitic. There's a strong precipitation gradient from north to south. The south is much wetter. There's a lot of natural vegetation in Belize. There's a number on that. Almost 70% is still vegetated. There's a lot of protected area in Belize. Something like 32% of Belize is at least on paper in some form of protection. And we were able to come up with 303 locations where we had freshwater fish collections. That included some historical work that was the original description of the freshwater fishes of Belize, a colleague in Mexico who had a number of sites, and then a couple of field seasons of collecting by Pete and his crew brought us up to about 300 locations for freshwater fishes. And so the approach was to use a protected area planning software program called MarkSAN. I know some of you are familiar with this and working with it as well. And what it does is basically iteratively sifts through alternative protected area designs according to a series of rules you give it to come up with the maximum target protection. We use species as our targets, maximum species protection for a given cost function. And so the most efficient portfolio, it looks at thousands of portfolios, meets our species representation goals. Our goal was to have 15% of the range of every one of our species included. It has to minimize various cost functions, and that cost function included, among other things, human threats. So we had a human threat surface. We had to minimize that cost. We have other costs I'll mention in a moment. And it has to minimize the sort of area that requires by a boundary criteria. So this is a software we're given a series of targets, and ours were, as I said, species to protect. It will come up with portfolios you can choose among, and you see how much, basically, how you would configure your protected area. So, walk you through the process. We have to define the extent of the study area, which was shown in this, and the rivers draining to the coastal waters of Belize. The planning units were individual watersheds, and so there's 36,000 small watersheds in Belize, and so those were those 36,000 units are what MarkSAN would sift through to find the 15% rule. We would create an environmental risk surface, shown here, and the risk surface is based on primarily land use measures, so urban area, agricultural land, road networks, things of this sort. And by various weighting rules, you get sort of an intensity map, a hotness map of those threats. And then, and this is a point I want to stress, the next thing that Pete did, and it was quite straightforward now, but inventive, is he routed those threats down rivers using essentially a watershed routing tool in ArcGIS, so that those threats, which were initially depicted as being, just sort of land-based, were now gathered up onto the river basin and moved downriver cumulatively. So, so it was a cumulative, flow downstream. Basically, the threats flowed downstream. This is water flowing downstream, which then had to be normalized to system dimensions. And so then we had an environmental risk surface, and this basically tells you the places you want to avoid. These are the places where, if you put your park there, you're putting it in the places where you're least likely to be successful. So that's what the environmental risk surface does for you. And then you define your conservation features, which are shown as being segments of rivers that needed to be protected. And the conservation features are based on the freshwater fishes. So to get the freshwater fish data, there's another modeling exercise that has to be done. I showed you a map earlier that showed the 303 locations that we have. And it looks pretty impressive at the scale of a map of Belize, but it's not very many data points when you're actually in a watershed, 2 here, 3 there, and so on. And so we used MaxAnth, particular species distribution modeling tool, And so we basically predict its ecological niche modeling based on landscape and climatic features. And so there are 120 species of fish in this that have been collected in these waters. For about 60 of them, 63 of them, there were enough observations, which we define as more than 5, to be able to build a satisfactory model. And so we were able to predict the ranges. So from the dots that you saw on the map, we developed a range surface for 63 fish species, which we then presume are representative of all the species in the system. We did, however, weight it in a particular way. And that was that we wanted to identify fish species that we thought should get essentially bonus points in the weighting system. And there were 3 categories of these. One was sub-regional endemics, species that have relatively limited range within that region. Some poselids and some cichlids. Apex predators, shown here by a snook, and migratory species shown by this particular mullet, species that are catadromous in their life histories. So these were given extra weight in the system to protect the migratory species, the apex predators, and the sub-regional endemics. We want to know where the current protected areas are, and then we can identify the focal areas and for both the migratory fish and the non-migratory fish. And the detail, some of you are interested in this, is that we identified the focal area for migratory fishes first, then we fixed that, and then we went ahead and because they had special corridor needs, and then we went ahead and ran Marxan again to pick up the non-migratory species. And once we did that, then we had our focal areas using this conservation planning software called Marxan. What we did after that was manual post-processing to identify secondary management in the site corridors. So here's how it comes out. The focal areas for migratory fishes, shown here on the map. 3.4% of the study area. That's really good. You don't want to need a lot of area. You want to require a lot of area. When you bring in the non-migratory fishes, you're up to 10.7% of the study area. Add in migration corridors, they don't take a lot of area, and then put in riparian buffers upstream for your catchment protection. And at this point, we're in fact around 15% of the area of Belize between our focal areas and our critical management zones. So that's a pretty satisfactory outcome. Interestingly, when you add in the catchments, you're up to 88% of the study area. And look at that, and that's probably not practical, and it probably isn't. And I think it in some ways returns to the point that full catchment management, except in very special circumstances, may not be a widely practical plan. There's only, to my knowledge, 2 other studies besides Pete's that have really built connectivity into freshwater planning. One uses a modeling software called Zonation, Mulanen's work, and then one was done ad hoc, but cleverly by Simon Linke in Australia. And Simon, who I know well and think very highly of, had the rule that you protect the entire catchment upstream of any focal area. And I think there's still, frankly, questions to be discussed about how feasible that is. When you overlay the areas that we want to conserve on protected areas, about half of them fall in protected areas. That's pretty good. That's probably also unique to Belize for a couple of reasons. Belize has a large existing protected area network, and it's also a consequence of the way we did our planning, which I didn't mention, but I'll mention now, which is another constraint we built into the model, was to start with protected areas and try to build your protected area network from existing protected areas before you went to non-protected areas. Again, I think a practical consideration. So I present this as an example. I think this is just a fledgling literature of trying to think through planning process for protected areas against myriad threats in freshwater systems. I think it's I give the credit to my PhD student, Pete Elselman. He really is the brains behind this. I think it's well done. There's 3 studies like it. They're all different. And I think we'll just see more growth in this area. I know people here in Julian's lab are working on this, so I'll be excited to see where they take the field as next steps. So to summarize, a freshwater protected area for Belize. If you leave out the catchment, total reserve network, including critical management zone, was 12.8%. Not bad. The framework that Robin and I and others have advocated really wasn't that hard to implement, so we think it has promise. So far as I can see, in the only couple of years since that paper has come out, it seems to be holding as people are comfortable with that notion of essentially thinking about freshwater protection as requiring a spatially distributed strategy. This is one of the very few studies to explicitly incorporate longitudinal connectivity, and so I think it's important for that reason. It does, I want to close with one comment, which is, from a management perspective, it's still complicated. Because from a management perspective, you've got the focal areas that require your management attention. You've got the critical management zones that require your management attention. And if you really believe that the whole catchment has to have some sort of management planning, then you've got that larger area as well. So, I think that the implementation of this still is going to pose challenges, but we're starting to get some ideas about how we might want to move forward. So, thanking a lot of people. Thank you for your attention.
We are running out of time, but we will definitely make time for a few questions. Do you have any? Julia?
I'm kind of struck by two things. Water flows downhill, right? And so that's a little bit, ocean is downhill. So when we think about creating protected areas in the ocean, we're sort of thinking about something fundamentally different. I really like the aspect of connectivity, which was incorporated in the Belize model, but I'm also struck by the fact that the type of threat that a freshwater system experiences sometimes flows and sometimes doesn't. Quite literally, sometimes the threat is that you're taking the water out of the system rather than putting something into the system, like pollutant stored in bases. And so I wonder, coming up with a freshwater protected area scheme that's still area-based, how do you deal with those really fundamentally different kinds of threats relative to saying protect here and not here?
Well, I think that's a really good point. We haven't spent a lot of time thinking about water withdrawals, although they're a significant issue. We haven't spent a lot of time thinking about arid areas, and I know that can put you in a whole different ballgame in terms of the management challenges you face. I would say, though, there's still that very simple but general dichotomy between threats that are in the place that you're, they're really close to the place you're working with, threats that are very far away, and I think that the freshwater systems are just very vulnerable to threats that are very far away. There's a litany of stories of really nice protected areas that have dams downstream and deforestation upstream, and chemical plants upstream, and so on. So we wanted to try to focus on those kinds of questions, but you make a good point.
Yeah, I wonder about the protected area approach. Seems to be pretty much all or nothing, like particularly regarding the catchment area. Different kinds of land use will have different effects on the watershed. And that, rather than looking at just whether you're going to protect it completely, which I guess means you have to be wilderness area, if you thought of extending this approach to looking at different kinds of land use, like different kinds of agriculture versus different kinds of forestry, it seems that it's kind of set up for being able to do that.
I think the point's well taken, and I believe we have in other writings, and I've certainly, most of my research, my hands-on research has been looking at land use impacts on river systems and alternative management plans and protection thereof. And I think once you move into the whole catchment, then it's all about management. You know, once you move into the whole catchment system, I think it's managing the matrix, and what the terrestrial people say, managing the land use aquatics people say, and mitigating in many cases. So then you get into issues of, you know, how much, for example, deforestation can you tolerate in a watershed if you have a riparian buffer strip? How much offsets can you get from those various management strategies? And I think that's another important framework, so I agree.
Maybe take one or two more.
Kind of going the next step from actually implementing a protected area, this has been pretty hot in the marine world, is incentivizing people to protect resources. So do you know if anyone's starting to go that next step in the freshwater protected areas to see, okay, if we're going to put up protected areas, there's going to be a cost. Either we have to buy the land or we have to prevent people from doing some kind of activities in there. I guess one feasible way that you could implement protected areas without actually having to put up a park is give people economic incentives to protect things like conservation reserve programs and whatnot. Do you see that as being, or has anyone started to look at the actual cost of doing something like the management plan in Belize or something like that?
So I don't know about direct cost analysis, but incentivization, you know, there is a literature on co-management and community management, including in freshwater, that shows some real success stories. There's also some not success stories out there, but where, you know, particularly from the strict issue of managing fisheries, where there's an economic value of being able to have that fishery be sustainable, and having shares that are owned by a community, or having the whole community responsible for being able to fish that lagoon or fish that section of the river. You know, then the incentive is clear, the economic return for the people is clear, and that looks like a really promising direction. When you get outside of that sort of direct reward system that comes from managing a fishery and into, you know, protecting these sub-regional endemic porcelias and cichlids because it's just nice to protect them, then it does feel more like a payment strategy. Either that land has to be purchased or people have to be compensated. And I think some of the folks working here on co-management have been telling me about activities in the Philippines that sound like they, you know, have some of those elements to them. So I think that could happen. Some of the big NGOs are now trying to find ways to make that happen. I'm not personally connected to it, I'm afraid.
I can add to that with the whole payment for ecosystem service field right now, it is moving into payment for watershed services. But typically, just like Dave said, typically you have some downstream user who's willing to pay, and it's usually has to do with water quantity or water quality, and a municipality or whatnot can pay upstream stakeholders to protect the water quality or water quantity because they have a commercial investment. But with fishing, especially small-scale artisanal fishing, the people who are benefiting are the same people who are paying, so it doesn't work out in a traditional CPS scheme. The last question.
Yeah, I was just wanting to get some of your ideas on ways that, or even if it's even possible, to test these. Obviously, they occur over a long time period, over broad scales, but has anyone done any sort of a substitution for space or time sort of analysis to look at what might be there?
It's a really good thought, so thank you. Trying to think about whether we could find examples of that. So we're just starting to see some of these ideas actually be implemented. The Belize plan has been adopted by Belize. Pete went to Belize and got on television. That was quite impressive. Really got a lot of publicity for what he was doing. But the main examples that come to mind, sort of a little bit off track, and we've got a paper coming out, and some other papers that come out recently, where people have asked the question, people have asked questions, you know, how well current systems are working, and demonstrated their failure. But what you're asking is some demonstrate the success of some of these new systems, and I can't think of an example, but we need to do that. Yeah.
There was a recent paper by Paul Ferrara, who's an environmental economist, calling specifically for that and giving an example or two from the terrestrial realm where that's been done, but calling specifically for freshwater conservation people to start doing that.
So that's up next.
Yeah. Thank you, David.
All right, thank you.